So thank you for joining us. This is the Community Efficiency Leadership Coalition, uh, also known as CELC, monthly webinar series. So thank you for joining us today. Today we're going to discuss the heat pump rooftop units, an underutilized energy efficiency and decarbonization strategy for low-rise commercial buildings. It's going to be presented by Guidehouse. I'm pretty excited about that. So really going to be learning about the Commercial Buildings Heat Pump Accelerator, recently launched by the U.S. Department of Energy, which aims to drive the adoption of high-efficiency heat pump RTUs available today and develop next-generation cold climate heat pumps. A little bit about our organization. So CELC is actually part of a program by SPEAR. We're South Central Partnership for Energy Efficiency as a resource. We're part of a national network of regional energy efficiency organization, also known as RIOs. We're one of 6, and we cover Texas and Oklahoma. And our mission is to accelerate the adoption of energy efficiency products. And we do that by developing diverse partnerships, supporting other organizations, supporting the Department of Energy and the State Energy Conservation Office, and then science-based resources, as well as training and guidance through policy. And as you can see, we're a 501c3. I want to talk a little bit about the program that I manage, CELC events that we have coming up. In July, we have 2 webinars, a building operator training opportunity, and then also one on resiliency through a West Texas city lens, specifically El Paso. And then in August, we'll be having a presentation on utilities engaging communities. And then in September, I do want to say and give a shout out that SPEAR's Industry and Policy Workshop will be occurring on September 19th. And then a little bit about CELC, you can become a member. You can also always go to our events, but through becoming a member, it's really to support local governments, cities, school districts, universities, and state agencies to furthering energy efficiency. And welcome to explore our website to learn more. And then we also have additional resources on our website, a City Efficiency Toolkit, a Texas Energy Adoption Toolkit, as well as templates and messaging for policy guidance, including energy plans and other support documents. And then we also have a YouTube channel with over 167 videos and training. So this program is sponsored by the State Energy Conservation Office and the Houston Advanced Research Center. So thank you so much for continuing your support for this webinar series. A little bit about housekeeping for this webinar today. Questions are welcome. You can put them in the chat, or you can also put them in the question and answer, which you'll see with a little quotation bubble, possibly on the bottom of your screen. And I will be moderating today, so I'll help and assist with asking any questions, or if there's any issues, please reach out to me. Presentations will be posted on our website, and then also we will have a survey that we'll be sending out. We'll post it in the chat, but we'll also provide that in a follow-up email within 3 days. And then you can also receive ICC CEUs from attending this webinar live. You do have to attend most of it. All the CEUs will be mailed out within 3 days, but you do have to provide a feedback survey to receive that. So again, very excited about today's presentation. We have fantastic presenters. I will stop sharing my screen now. And if you want to go ahead and get started. And again, our speakers are Jim Young, Saad, Saleem, and Rachel Lebendinsky.
Thank you, Sean. And hi, everyone, and thank you for joining us this morning. So as Sean mentioned, so the topic of today's discussion is all around commercial buildings and specifically heat pump rooftop units, which are kind of ubiquitous across the commercial building space, but often underutilized as a potential asset for how building owners and operators and portfolio managers can look at ways to improve their energy efficiency and reduce emissions for their commercial building operations. If we go to the next slide. So there are rooftop units is what we'll talk about are the most common kind of HVAC category across commercial building space, particularly for low rise, 1 to 3 story type buildings, and really aren't thought about until they fail or need to be replaced. And but they can be a key decarbonization strategy for building owners. But the problem is that heat pump rooftop units have been around for decades, but just really haven't had a lot of traction for a number of reasons, even with leading organizations with greenhouse gas emissions reduction goals. So to try to go and raise awareness and develop kind of case studies, increase adoption, provide some resources, the U.S. Department of Energy recently launched the Commercial Buildings Heat Pump Accelerator, and Guidehouse is helped part of that, and we're working with Spear and others across the country to as part of the accelerator, and we'll get into that a little bit later. So that, I mean, the goal here, we'll talk about kind of what the technology is, what are the key barriers and opportunities around heat pump rooftop units, and I guess particularly for this focus in the Texas Oklahoma region. We'll highlight some of the case studies that have been prepared to date, some of the findings around energy and emission savings from upgrading to these different types of heat pump rooftop unit products, and then lastly, would love for you all and your colleagues and others across the Texas and Oklahoma region to join the accelerator and provide your feedback and inputs, and we'd love to work with you as part of this initiative over the next couple of years. Go to the next slide. So myself, I'm Jim Young. I'm associate director and help to lead our work on the accelerator. So Guidehouse is a management consulting firm. You may have heard of us previously as Navigant Consulting from several years prior. But also joined by my colleagues Saad and Rachel. I will let them introduce themselves.
Hello, everybody. Thanks again for attending this webinar and letting Guidehouse speak on the commercial building heat pump rooftop unit campaign and challenge. So I'm a senior consultant at Guidehouse since the last 2 years. My experience is on the HVAC and R sector mainly. So yeah, I assist Jim in these market transformation projects, and we also work with the Department of Energy on the Appliances and Equipment Standards program to regulate and enforce the energy efficiency of HVAC and refrigeration appliances. Thank you.
Hi, everyone. I'm Rachel Lebendinsky, consultant with Guidehouse. Been here for about 2 years, working on this campaign and a couple other building decarbonization programs with the Department of Energy. I'll hand it back to Jim.
Thank you. So I guess some of you might be very well versed in kind of the different types of HVAC products, but it's always good to kind of start off with a view around what is a rooftop unit? What does it look like? What are the functions? So we kind of have a few pictures here of different types of rooftop unit systems, but generally speaking, I mean, they're packaged. They'll be kind of crane lifted into place on top of a restaurant or school or warehouse or office building, big box store, and so they're typically sized 5 to 20 tons, sometimes larger, and so if you think of like a big box store, they might be a dozen or two across, providing zonal heating, cooling, and ventilation for that space. So they come in a lot of different varieties. So some, I mean, all of them are kind of designed to provide cooling. In terms of heating, you might find them as either using natural gas, kind of burning natural gas as part of the system. But it's all packaged within the same rooftop unit. So some might be having natural gas furnace on board. Others might be using electric resistance coils to provide the heating function. But because all of them will have a vapor compression, electrically driven cycle for the space cooling application, there are heat pump models available that kind of reverse that vapor compression cycle and can utilize can provide heating for the building through that package. And then typically in these situations where there's the heat pump operation, there'll often be either electric resistance or natural gas backup on the system to supply in colder days below, could be anywhere from 20 to 30 to 5 degrees is when that backup would kick in. But yeah, these are all commercially available. They come in a lot of different shapes and sizes, and from all the major manufacturers. So if you haven't seen one or worked with one specifically, take a look around the next time you're driving around, or if you're on Google Earth and you see a large flat building, the little things that are small little gray or tan rectangles, those are rooftop units. So the pie chart on the right is from the Energy Information Administration's CBEX survey, which kind of takes kind of a national look at characteristic and energy consumption and emissions data from thousands of commercial buildings across the US. So one of the really interesting things is, so rooftop units have been available for decades, heat pump rooftop units similarly available for decades, but really only have market adoption for around 20% of the rooftop unit market. Even in places that are, so you think more northern regions, yes, the traditional commercial heat pump rooftop unit technology faces shortfalls of capacity and efficiency in very cold weather, but even in kind of southeast, southwest California coastal regions, adoption has been fairly low, and we'll get to that for some of the reasons why. All the major manufacturers supply them, and but yeah, there's just not been a kind of a concerted effort to date. But the kind of increased focus on commercial building decarbonization kind of raises up the profile of like, well, this can, if this is for the building types that use rooftop units, heat pump rooftop units can provide a significant emissions benefit, and then what we're finding is also an economic benefit as well. So the whole idea around here is kind of increasing awareness of it as a solution to support everyone's sustainability goals. So some of the barriers, and I mean, a lot of these are common across many of the energy efficiency measures that are probably discussed on these webinar series, but I mean, some of the bigger factors, economics. So for commercial building owners, particularly those in lease spaces, upfront costs are more important than operating costs. Heat pump rooftop units will generally have a pretty modest price premium relative to those using electric resistance or natural gas heating. But even in a case of if there's any price premium, if the building owner is not paying the bills, but they're purchasing the equipment, they'll purchase the cheapest option. Availability. So in the most cases, there's not proactive equipment replaces, but rather reactive replacement. So if replacements occur on failure, building owners will tend to go in and want to have whatever's available that can be installed tomorrow or the day after. And so if, as we mentioned, heat pump rooftop units are not adopted as widely, so they may not be locally available in the capacity and type that's needed. So that's one barrier. Performance-wise, so cold climate definitely is a consideration, and part of, as Rachel will talk to you about, part of the accelerator is meant to develop next generation cold climate products. But even for let's say warmer regions, there are unique building considerations for using heat pump rooftop units rather than those that use natural gas heating. So nighttime setback, I have to think about it a little bit differently. Just because of the morning recovery period will end up being longer if you're using heat pump systems, which are generally don't have a very rapid heat rise, but more gradual heat rise. And then also a situation where there's high outdoor airflow rates. Similar situation is that, yeah, the heat rise that might be expected, particularly on the coldest days, for buildings that have very high outdoor air fractions coming through that rooftop unit for ventilation can be a challenge. On the infrastructure side of things, so yeah, if depending on kind of what the current situation is, there might be kind of size, weight, or electrical capacity considerations. If it's a building that's already using a rooftop unit for cooling and has electric resistance heating, there would be no expectation for electrical needs. But if it was using natural gas heating, there might be an additional electrical supply line that needs to go up to the roof to if it's an all-electric using a electric backup. Some of the other pieces, so awareness, that's definitely what we're trying to accomplish today, is that it's not very well understood as a decarbonization technology. But the other piece that kind of hinders this that we were looking at is there's been a lot of work recently around, well, yeah, for government or energy efficiency programs, traditionally haven't allowed fuel switching or haven't been able to incentivize conversion from natural gas to electric products. So that's starting to change a little bit on residential, but even on commercial, we're seeing that that's been a slower change. And so yeah, there's just, if you're looking at incentive availability, going back to that upfront cost situation, so the incentives will be designed around cooling, but yeah, they won't necessarily allow for that fuel switching aspect. With all this in mind, the accelerator that we're working with as part of for DOE, and then probably over 2 to 3 dozen partners so far, we're trying to raise awareness, develop a set of resources to provide that information to building owners, contractors, sustainability professionals, engineering firms, to have understanding of what the opportunities are from this technology. So we've there's a big opportunity, a whole host of we have 99% of commercial buildings are less than 200,000 square feet, and particularly the vast majority of them are low rise. So it's a big market opportunity. The technologies today for all electric systems will work great in the coastal Southwest, Southeast, and Mid-Atlantic regions. And then manufacturers have developed dual fuel products that have will use the heat pump as the primary, but if it gets too cold, they'll switch over to the natural gas as the backup, which are suitable for cold climates today. And then we'll talk about developing the next generation products for the cold climate products. So some of the key areas that we're key partner segments that we're working with, big box retail, school districts, office spaces, warehousing is actually a significant one for minimum temperature conditions. But yeah, these are applicable across a wide range. As long as you're not kind of high-rise buildings, you'll find rooftop units most likely. So with that, I'll turn things over to my colleague Saad, who'll talk through some of the energy and emissions modeling.
Thank you so much, Jim. So one of the big partners that we have that is helping us in this effort is the National Renewable Energy Laboratory in Colorado, short for NREL. So they have a tool called Comstock, which is this effort which can help manufacturers, energy modelers, or engineers in general to understand that, okay, what kind of emissions, energy, and operating cost savings we can get if we replace our existing HVAC equipment with something that is more efficient, something that is using a different fuel. So most of this provides you the annual energy consumption, but at an hourly level. So it is extremely granular. Primarily, the work is done in Open Studios and Energy Plus, if you're aware of those software tools. As Jim pointed out, that the main commercial building types that we are interested in are offices, primary and secondary schools, big box retails, and warehouses. And so we extracted part of Comstock's data that is available on these establishments for different regions across the US. You can see that in the table on the right. We are basically looking at a major city in each of the climate zones so that we can have a variety of, okay, how clean is the grid? What is the climate and what are the different utility rates? And the goal here was to see that if we look at the baseline cooling and heating system of that building, and in this case, the baseline is referring to an AC rooftop unit with heating provided by either natural gas or resistance heat, and then replacing that with 3 different upgrades. So upgrades A and B are basically variable speed heat pump rooftop units. So this means that basically we're upgrading to higher efficiency and premium equipment. And for upgrade A, the backup heating is electric resistance. So even though it's a heat pump at extremely low temperatures, it will switch to electric resistance heating. And for the upgrade B, it will switch to predominantly natural gas. It says there it's the original heating fuel when compared to the baseline, but for most of the buildings, the baseline fuel was natural gas. And then there is upgrade C, where we looked at a standard performance, or what we like to call a single speed rooftop heat pump rooftop unit. And here the backup was provided by electric resistance. And again, just to clarify that the building stock that is in Comstock currently is based on the 2018 building stock. So the baseline is basically referring to the minimum efficiency units at that time. And at that point in time, if I recall, the integrated energy efficiency ratio for rooftop units was around 12.9. And you can see that for variable speed units, it is significantly higher. In the footnotes, it's around 17. And then for upgrade C, we're looking at standard performance of the units today. And the integrated energy efficiency ratio for that is 14.1. And just a little tangent to that, this metric compares the average space heating or space cooling you're providing to the input electric energy over the entire year. It is a weighted average of the different load ratios of the unit, and the weighting is built up on, okay, how much time will that unit spend at a specific load. Okay, so we've now set up the stage for all the inputs and what we're trying to look at. I'm going to show you, in the interest of time, we're going to only focus on offices. And I'm going to show the greenhouse gas emission savings and the savings in the utilities across all these locations. Okay, so this is again upgrade A, where you have a variable speed heat pump rooftop unit assisted with resistance heating. So we are seeing higher greenhouse gas emission savings in the northern parts, but still, if we focus here on Dallas, Texas, we are seeing greenhouse gas emission savings that are going up to 33%. Whereas in Minneapolis, that number is up to 55%. Looking at the utilities, again, significant savings pretty much across the board. They are between the 20 and 30% mark. And for Texas, climate zone 3A, we are seeing something around 27%. Now, this is upgrade B, again, for office buildings. And now we're looking at, instead of resistance heat, we are going to go with natural gas. So again, in terms of greenhouse gas emissions, the savings are slightly higher in the north, but still we are seeing the same 33% from Texas. And in the 20 to 30 range in the southern part of the country. And the utility the utility savings are again around 26 to 27% for the south. Okay. So this is the last upgrade where now we don't have a variable speed unit. We have a standard performance heat pump rooftop unit, again with resistance heat. So if we just focus on the south here, you will see that the greenhouse gas emission savings for climate zone 3A, where Texas is, are lower than upgrades A and B. And so are the utility savings. And this is again expected because now you're getting less space heating and less space cooling for the amount of electricity you're putting in. That means, okay, you are burning more, I wouldn't say burning, but you using more energy to get the same space heating. So it's very obvious that your savings when it comes to the operating costs and your CO2 reductions are not as high as they would be if you were using a variable speed unit. Okay, I think we can move on to the next slide, which summarizes things. So let's just look at, we're going to look at utility savings and the emission savings one at a time. So for utility savings, what we are looking at may not be extremely visible here, but upgrade B seems to be on the top, where you have a high performance heat pump rooftop unit paired with natural gas or any other kind of fossil fuel as the backup. So that seems to be that seems to give you higher utility bill savings. Now you will notice here that upgrade A at some locations, specifically in slightly colder climates, is also giving you negative emissions. And again, this is because upgrade A was using variable speed units and it was using a resistance heat as the backup. And so at lower temperatures, your resistance heat is running for longer time, and hence you are using more electricity there. So again, with Texas, we are seeing that upgrades A and B actually are similar in terms of greenhouse gas emissions. But across the board, we are seeing that upgrade B seems to be a more viable option. But let's go to the next slide. So this is showing you greenhouse gas emission savings. So first thing here is that, okay, there is no negative number here because what we're saying here is that, okay, even if you move to your standard performance rooftop unit, which is upgrade C, you will get a net positive. And again, we're noting that for Texas, upgrades A, B, and C, A and B have like similar savings, and upgrade C is again on the lower end, not just for Texas, but almost across the entire country. So this gives us, so this leads us to believe that, okay, variable speed heat pump rooftop units are the solution, but if you want to go for a cold climate heat pump rooftop unit or a dual fuel heat pump rooftop unit, so again, a dual fuel is upgrade B, and a cold climate would be something like upgrade A. That will very much depend on where in the country you are located at, how clean is the grid, and what is the relative cost of natural gas and electricity there. So with that, that concludes the energy modeling, and I'll hand it off to Rachel from here.
Thanks, Saad. Apologies, the screen I'm sharing from is over here.
No worries.
So to achieve the savings that Saad was just talking about, as Jim introduced earlier, the DOE's Better Buildings Initiative launched this commercial building heat pump accelerator to increase adoption of the currently available technology and the technology that is being developed. So the accelerator is working with building owners and operators, manufacturers, and other stakeholders in the energy efficiency industry to push the adoption and try to get those savings that Saad was just mentioning. So the campaign arm of the accelerator, which Guidehouse is helping run, the goal is really to increase the adoption of today's commercially available technology. And to do that, we're highlighting organizations that have adopted heat pump rooftop units or plan to adopt them, providing resources to building owners just to increase awareness. One of the big barriers Jim was mentioning. People just don't really know about this technology and all of the savings that they could provide. Providing other educational resources, developing case studies that showcase successful adoption of heat pump rooftop units, so building owners can actually see not just the model numbers, but this actually in practice. So that's the focus of the campaign. And then the challenge, which is being run by the National Renewable Energy Lab, or NREL, that is to advance the cold climate technology. So those more northern regions where they weren't seeing as much savings with the electric resistance, pushing that technology and getting the heat pumps to be more efficient in colder temperatures. And through that, manufacturers sign up to develop the technology, test the performance, and then do field validations with better building partners. And those heat pumps are going to be available starting in 2027. So the partners we have so far, this accelerator launched about 2 months ago at Better Building Summit. 8 manufacturers have signed up so far to take part in the challenge. And then for the campaign, we have 16 partners, which include some large end users, some small end users, and then other utility and energy efficiency organizations like Sphere. Sphere's on this list. Sphere's on our website, which is very cool. And anyone can join, manufacturers, end users, any other organizations that want to just help us increase the adoption of heat pumps. So you can reach out to any of us, and there's also a form on our website. So, and maybe we can drop the link in the chat, and then our emails will also be up here later. So a majority of the resources we want to develop are case studies, because they describe how these organizations have made the decision to go with heat pumps, how they're navigating those decisions within their organizations and have overcome some of the barriers Jim mentioned. And they can also serve as a data source. So in addition to the modeled numbers, these have actual real life savings that we can point to. And it's important that we develop a large network of these case studies so that a lot of building types and climate zones are represented, so that as many building owners as possible can see their buildings and how it would go for them. So we have 2 case studies so far: the Los Angeles Unified School District in California and the Columbia Association in Maryland. So LAUSD has replaced 65% of their decentralized units with all electric heat pumps. So with that electric resistance backup. And this has reduced their heating emissions by 33% and it saves them about $140,000 every month on utility costs, which is pretty significant, but they're also a very large school district. And this is a really good case study because they were able to justify that higher upfront cost because to their decision makers, because it got them closer to their sustainability goals. So depending on the organization's priorities, there are different options for savings and how you can justify that to the decision makers. Columbia Association has been replacing their gas-fired rooftop units with dual fuel units as the equipment fails, so one by one. And an early pilot has them projected to reduce their natural gas use by 70%. And even though Maryland is technically in the region where it would be feasible to use the all-electric heat pumps, they are reserving their spare electrical capacity for future heat pump projects. As Jim talked about, not all buildings have the electrical capacity for all electric heating and cooling. So instead of upgrading the electrical capacity of the building, dual fuel is a good option to avoid that large cost of upgrading electrical capacity. And even though they're not replacing all of the rooftop units at once, it's really important that they're planning on it now to avoid having to just get whatever is available soonest when a unit fails. So it's really important that they have that plan in place. So in addition to case studies, we are developing a lot of educational resources, like a decision tree, so building owners and other stakeholders can evaluate both site level and portfolio level what the best decision would be for them. Fact sheets just to provide some basic information. Not everyone knows what the heat pump rooftop unit is, what the benefits are, how they operate. So some basic educational materials. And then all of the information Saad went through will be on the website, estimates for the energy savings, the economic savings for every climate region for the different building types. And then other resources we're considering are the dual fuel switchover guide. So a guide going through the controls. And that's more for the dual fuel models. So at what temperature to switch over from the electric to the gas backup, because that can significantly impact your savings. And then a guide through upgrade processes and different incentives. So different utilities across the country and state and local governments have incentives to install heat pump rooftop units. It obviously depends on the region, but going through those so that building owners are just aware of the financial help and rebates they could get. And then in terms of joining the accelerator, building owners and operators can join as participants. So they're getting that free technical assistance, access to all the resources, help from us, and just guiding you through the decision-making process and what that could look like for your organization. And then recognition from the Department of Energy being on the website, just recognition for your organization's commitment. And then other stakeholders like SPEAR, the utilities, manufacturers, all of the other energy efficiency organizations join as supporters, and they're just committing to help us raise awareness and adoption of heat pumps, and they also get recognition from DOE. So this is the link to the Accelerator website. Also put it in the chat. This accelerator, this campaign is really to help you guys. It's to help building owners save money, save energy, promote the work that you guys are doing, do the case studies. So if you or someone you know is considering their HVAC options, or if you've actually installed heat pump rooftop units, we would love to develop a case study, help amplify the work you're doing. The case studies can be for a project that has already been done, or a future project, or one that's currently ongoing. We really just want to work with building owners to help this campaign. So this is all of our contact information, the link again, and we're welcome to any questions.
Thank you so much. I have a few for you all. I haven't seen any in the chat just yet, so those of you who are attending, please put them in the chat. I actually, while I'm asking Jim, Saad, and Rachel some questions, I'm going to release a poll because I'm very curious kind of person. So I want to see first, those of you who are attending, what type of rooftop unit do you have on your building? Is it natural gas, electric resistance heating, or a heat pump? While we're waiting for responses, so far we have one. I have some questions going back to the accelerator. So whenever you talk about like joining as a participant, I know a lot of questions come into mind from organizations of what does that mean exactly? How much technical assistance do you get? Is that just like 1 hour of a connection time? And then also with the resources of being a part of a case study, do you get some hand-holding and walking through the process also with figuring out funding and the costs for your case study? What does that look like?
Sure, good question. So we can kind of, I mean, the easiest thing to go say is that we'd love to talk to everybody individually, because it's, if you're a school district that has say hundreds of buildings, or you're kind of like an individual building owner for a restaurant or something kind of small, the scale of how we can go and support will vary. And for the case studies, we really want to make it as easy as possible for people. So Yeah, generally that's a 1 hour type kind of conversation, and then we'll kind of put that together, share it with you to make sure everything's kind of correct. But we do have a few partners that can offer monitoring and verification services in different regions. So that's also an opportunity of, yeah, if a group is considering this and would like to say, hey, all right, we'll pilot this at one site. We'd love to get to capture some data to understand. We can also kind of talk about that and what the different opportunities that the DOE can provide. I do want to clarify that the DOE is not, there's not kind of money that's associated with this. So it's there's not federal money that will be going directly to participants for this project, but we can work with you to identify in your area if there are any incentive programs that are available that would, for your region, that would be eligible for your types of projects.
And signing up as a participant also doesn't mean you have to install anything. Signing up is really just saying that you will consider it and talk to us at least once and look at all the resources and just have it in the back of your head. But you're not signing up and committing legally to put a heat pump rooftop unit on your building.
Thank you for clarifying that, right? Because there's some people who are applying for CPRG funds, and part of it is exploring these type of opportunities. So I think that that's a really great way to say that you're exploring by signing up as a participant, but not agreeing to install a heat pump RTU. And it's interesting too, we got about 5 people participating in our poll over here, and so far natural gas is the most popularly used RTU, and then electric, and right now there has not been a heat pump. So I'm going to go ahead and end this poll, and there's a question in the chat that I'll ask, and then I have one more that another poll I'm going to release, and maybe we can get some more participants. Is there a timeline for the spec being released, and will it have a dual fuel component? And whoever answers that question, please uncompact that for us a little bit further.
Sure.
Well,
Rachel, would you mind jumping back to the slide we had on the campaign versus the challenge? So good question. So there was this decision made to launch the challenge and kind of recognize the manufacturers that are committing to it without releasing the specification. And DOE and NREL and the manufacturers are all working together now to kind of finalize what that specification is going to look like. Because it's the goal of that is to push the technology development much higher than where it is today, but not too far that it can't be accomplished in the next 3 years. So, and even before then, to go and have lab testing and field testing. So the groups are all trying to find the right balance. So the specification has not been released to date, but will likely be released sometime later this summer or early fall is the latest guidance that we've heard. In terms of kind of what will be included, I think that's still TBD. But so the question is about is it going to be all electric or is it going to be dual fuel? That's a good, and I think it's something we're going to have to go and see further. But I think there is some recognition that a variety of solutions are going to be needed, particularly for colder climates, where a lot of commercial buildings do have a high outdoor air fraction for that ventilation load, and if it was, let's say in northern Minnesota, kind of a healthcare facility that or school that has high ventilation rate, it would be very challenging to try to do that all electric without a dual fuel option. So I think that there's consideration for both, but the final specification is still under development.
thank you for answering that. And let's see if there's any other questions in the chat. I have another question, and I'm glad that we talked about that, and it was actually about manufacturers. who is your current manufacturer that you have for your RTU. So we have about several people. If you could just give us an answer on who you currently have, because right here is I went through and I listed all the partners for this accelerator program, and so if you're selecting any of them, like I see Aon, that you could actually reach out to your manufacturer and say, well, and also hopefully reach out to Guidehouse and say, hey, tell me more. This is, you're the manufacturer I've been using, and learn more about what their participation in this accelerator program is.
And one more note on that is that, yeah, the products that will be developed will be field tested at partner sites. So if you already have an existing relationship, you can, we were having done this on the residential side, trying to find the right partner for each manufacturer can be difficult. So yeah, if anyone's interested, you could get in touch or pass along your name to us and we can share it as well.
And tell me more about being the right partner. What kind of criteria are you looking for?
Oh, I think that's still going to be under development, but and it's going to vary. And I actually I probably shouldn't say too much about what that may entail, but yeah, actually, I'll kind of leave it at that.
Okay. Well, that is a great opportunity. And from the responses, it looks like there's a couple of people that are utilizing manufacturers that are partners. So again, you all have mentioned about putting your information in the chat for people to reach out to you. Here's a great opportunity. And then I also had asked the question too at the same time, is how familiar you are of heat pumps. And so far the responses, 40% are saying aware, and then 40% knowledgeable, and then just 1 or 2 are saying no knowledge. So I do say that you guys have your work cut out for you, but it looks like almost, half of your audience today are aware. So that's pretty exciting, although no one has a heat pump. And this is mostly a Texas and Oklahoma audience. So no one's really installed these type of RTUs that you want to promote, but I think that this is demonstrating there is an interest. So let's see if there's any more questions out there, and I had another one. So if nobody else has a question they'd like to put in the chat. So do you all already have some partners here in the state of Texas or in Oklahoma that you know of?
So many of the larger national ones, that Target's, Whole Foods, Amazon, I know we'll definitely have presence in the region. But yeah, we are looking for others in particular. So a lot of our case studies are we have some in the works that are kind of more colder regions, but we also want to kind of get more moderate regions. And so we'd love to partner with anybody who has done installs or is considering installs to kind of highlight their process for it, because it's the southern US is kind of a very clear opportunity where technology capabilities, if the right partner has kind of a sustainability goal that they're working towards, and kind of bringing those two together can actually make it a very good connection, so that's the story we'd like to tell, and trying to build out this case study list so that people have visibility in their region or their building type, for how we can raise that awareness.
Well, I know in Central Texas there's quite a few companies you could work with, and we have just down the road an Amazon warehouse. Well, it looks like there's no other questions, and This has been a very thorough presentation. I greatly appreciate it. And I also appreciate how you all started it off and really kind of did a higher level explanation of RTUs. So here is a way to reach out and learn more and get involved in Accelerator. And again, we will be posting this webinar on our YouTube channel. And I don't have any further questions, but thank you so much for your time, Jim, Saad, and Rachel, and very excited about this, and we'll promote it as much as we can through Spear. And thanks again. I learned quite a bit, and especially exciting about the analysis and data work that you all are gathering.
Thank you for having us.
Yes,
Thank you.
thank you, Sean, and thank you for everyone for attending.